All right, so 10.4, other similarities. Okay, so we've done different types of similar triangles, and these ones are a little different, but we'll still be able to find the missing parts. So last time we talked about proofs. When we have these types of similar triangles, we won't be needing to prove these, all right? So there's two things we'll need to learn. First is the difference between angle bisector and medians. All right, so let me change my color. All right, so angle bisectors. Okay, angle bisector is a segment that cuts an angle in half. All right, so for example, this one, that would be BD. All right, these two angles were cut in half, and that is our angle bisector. Okay, median, if you look at those, it kind of looks similar, but median is a segment that cuts a side in half. Right, so this is the median that cuts this BC into two equal parts. All right, so the median here is AD, but what's being cut in half is BC. So BC is cut in half by AD. All right, and so we'll be using that information when we solve some of these problems. So this is just these aren't like the real problems that we'll be having, but this gets you an idea of the difference between angle bisectors and the median. Okay, so this time we're doing angle bisectors. So we'll be cutting an angle in two. So let's look at A. Find the indicated measure given by the segment of an angle bisector. So they want us to find UST. So UST. We want to find this big angle, all right? And they give us and say that angle M, this angle, is 36 degrees. So what would be this whole angle? Well, since this is a angle bisector, we would know that angle 1 is also 36, or the whole thing is 36 plus 36, which is 72 degrees. All right, so just getting a little used to bisectors. They give you XYZ, or XZY, XZY. We know that this is 36. What is the measure of 2? So we just cut 36 in half, which is 18 degrees. All right, C, this time they give us a measure of 2, which is 9x plus 2, and that measure 1 is 8x plus 6. All right, and we know since this is an angle bisector, we know that those two angles are equal to each other. So measure angle 2 is equal to the measure of angle 1. So 9x plus 2 is equal to 8x plus 6. Combine like terms. Let me change my color. So we subtract 8x from both sides. That cancels. And then we can subtract 2 from both sides. That cancels. So we end up getting x equals 4. All right. And then D, they give us measure 1 right here. And they also give us measure TRS. So TRS is, let me get a different color. TRS is the whole angle. They want us to find x. All right, so you may want to think about that, maybe pause and see if you can do this problem by yourself. All right, so if we realize that we have M angle 1, the measure of angle 1, plus the measure of angle 2 is equal to the measure of angle TRS. So if you add measure 1 and measure 2, then that gives us the measure of TRS. All right, but since this is an angle bisector, we know that the measure of angle 1 is equal to the measure of angle 2. All right, so we can plug these in. We could say 5x plus 4 plus 5x plus 4 equals the measure of TRS, which is 11x plus 3. Combine like terms and solve for x. So 5x plus 5x, that gives us 10x. 4x plus 4x is 8, equals 11x plus 3. And we could subtract 10x from both sides. And then we could subtract 3 from both sides. And we end up getting 5 equals x. And that's what they're asking for. Okay? All right. Then let's learn about medians. Okay, so we said median is a segment that cuts a side in half. So if this is a median, it says find the indicated measure given that the segment is a median. Okay, so this is a median, which means that PF and FQ are congruent. All right, it cuts that line PQ right in half. So they want us to find FQ, this part, if PQ, this whole thing, is 10. All right, so we'd know that FQ is half of that. This would have to be 5, and this would have to be 5. So FQ is equal to 5. All right, so maybe pause and see if you can do the other problems. Okay. This time, we know that this and this, those are medians. Okay, bisect that line in two, and then these would also be congruent. All right, and they want us to find MG. All right, MG, which is this part, if EG, this whole part, is 1. Okay, so if EG is 1, MG has to be 1/2. Okay, and then here's another problem. So we know that these are congruent. It says find x if f or GF is this whole thing. This whole thing is 2x minus 1, and CF, which is just this part, is x plus 5 divided by 2. All right, so we know that CF is also equal to GC, all right, because that is our half of our GF, all right, so we could say the whole thing, 2x minus 1, is equal to CF plus GC, or we could say 2 times GF, or CF, okay? So we could just multiply that by x plus 5 divided by 2. Those would cancel. We get 2x minus 1 equals x plus 5. Combine like terms. Cancel, cancel. We'll get x equals 6. And that's what we're asking for. Find x. All right. Last one. D. Find x. So here, before we even look at that, we know this is a median. Okay, so that means that this is congruent to that. Find x if FE, which is the whole length, this whole length is 2x plus 4, and ME, so ME is this part. This is very similar, all right? So we know that ME is also equal to MF. All right, and ME plus MF equals FE. So if we add both of these halves, it will give us the whole. So we could plug those in. We could do 2x plus 2 plus 2x, or that's minus 2, I'm sorry. 2x minus 2 plus 2x minus 2 equals FE, which is 2x plus 4. Okay, combine like terms. That'll give us 4x minus 4 equals 2x plus 4. All right, and then we could add 4 to both sides. That would cancel, and subtract 2x on both sides. We get 2x equals 8, or x equals 6. Sorry, 4. X equals 4. Sorry. X equals 4. Okay, those cancels. 8 divided by 2 is 4. All right, okay, so there's some examples. My understanding is there may be one of each of those, a median problem and a bisector problem on the test. Okay, and then there will also be problems that are like these. Okay, angle bisector similarity. So, and the problems that we did over here, these, we weren't finding similar triangles or anything. We were just realizing if we knew that we had a median, then the line will be cut in half equally, or if we had bisectors, angle bisectors, that the angles, the two angles are equal to each other, so angle 1 and angle 2. All right, so we'll also be having some problems where we'll need to solve similarities. All right, so whenever you have an angle bisector is a triangle, or I'll just read this to you. Angle bisector similarity. An angle bisector is a triangle in a triangle divides the triangle into two similar triangles. All right, so we're saying that this triangle is similar to this triangle. They're not equal, they're just similar. All right, and if that's the case, then we have this situation. Okay, so we'll do the comparison, or what is it called? Proportions. Okay, the proportion of A to B is proportional to C to D. All right, so again, you could have your smaller triangle on the top and the bigger on your bottom, or vice versa. It doesn't matter. All right, so let's look at this. We want to find this question mark. Okay, so we'll put an X there. The line that corresponds is going to be 2. All right, we'll set that equal to, we'll use the same triangle for the top, 8, divide it by 4. Okay, multiply both sides by 2, and you end up getting x equals 4. So it's basically the same thing, all right? If you use the same like setup that we did with the other problems, let me see if I can go back to like these problems. So what we basically did is that's not what I'm looking for. Maybe one like these, okay? So this one maybe we didn't do this one, or maybe not. But basically we take the larger triangle and we divide it by its corresponding side. So 91 divided by 26. And then question mark here was x, but divide it by its corresponding side, which is 20, all right? So it's basically the same type of thing we need to solve for x. All right, sorry if that gets you a little nauseous, okay? So here I'll look over this one more time. So our question mark That's our x. Its corresponding side would be 2. And then 8 will go on the top. For this problem, I have the large triangle on the top and the smaller triangle on the bottom. Just turned out that way if I chose to have x be on the top. And then we divide by 4. Okay? So let's do some more of these examples. Hopefully you can get this pretty quick. So this is what we're looking for. 2x minus 6. Its corresponding side would be 10. And then that should be equal or proportional to 6 divided by 15. Okay, so on this top, we have the small triangle on the top and big on the bottom. All right, so, sorry, excuse me, still trying to get over this cold. All right, so you would maybe want to multiply both sides by 10. Sorry. Cancel, we get 2x minus 6 equals 60 divided by 15, which is also equal to 4. Sorry. Need a drink. All right, and we could just add 6 to both sides. 2x equals 10, and then divide both sides by 2. So x equals 5. All right, so not too bad. If you were following along what we did in 10.2, 10.4 should be fine. All right, so here we have another one. We're going to use our big triangle. So we're going to do 6x minus 4. Divide it by its corresponding side, which should be 8, equals 15 divided by 6. So here we have the big triangle on the top and small on the bottom. Sorry. All right, and then you just need to solve for x. Multiply both sides by 8. We get 6x minus 4 equals, I'll just put this in my calculator. All right, I guess I have it right there. So we'd get 20, I think it's 20. So then we'd add 4 to both sides. So we get 6x equals 24. And then we just divide both sides by 6. So we get x equals 4. All right? All right, next we have parallel line similarity. So we haven't really talked about this. Perhaps we've talked about a little bit when we were doing our proofs. But when we had our proofs, we knew what all the sides were. All right, so parallel line similarity. A line is parallel to one side of a triangle, of the triangle split, a line parallel to one side of a triangle splits the parallel into two similar triangles. All right, so we would say that this triangle is similar to this triangle. All right, so for this type of problem, all right, there's kind of like two ways you can do this the exact same way we've always been doing. So we could use our small triangle and we could use our large triangle. Okay, that's one way you can do it. So if you wanted to, you could go, let's say we're looking for this question mark. All right, so we would perhaps want to have the question mark, we'll say will be x plus 15. That is the long side of the triangle. And divide it by 15, which is the corresponding side. Should be equal to the whole triangle here would be 32. 32 divided by 12. All right? At that point, we can solve. We can multiply both sides by 15. Okay, we get x plus 15 equals, let's see what we got. 32 times 5 divided by 12. I guess that just simplifies to give us 35 times, oh, it's 15 times by 15. All right, hang on. All right, so that gives you 40. And then we can just subtract 15 from both sides. Right, so we get x equals 25. All right, so that's one way you can do it. And that's the same way I've been teaching you how to do it the whole time. So if you're happy keeping it that way, that's great. Another way you can do is when we have these parallel lines, we can find that the question mark, we can do x divided by 15. So the proportional side would be 15 equals 20 divided by 12. So this is not a lot less work. Okay, so multiply both sides by 15. And then you would plug that into your calculator. So you get 20 times 15 divided by 12, and you get 25. All right? So I'll probably be doing that. You're welcome to do the whole thing as well, but this only works when we have parallel lines. All right? So, let's look at this one. Question mark x, the corresponding side would be 15, equals 12 divided by 9. Multiply both sides by 15. We get x equals, let's see, 12 times 15 divided by 9 ends up giving us 20. Okay. Next one. Okay, so here they kind of give us this whole thing. So if we have no idea what this could be as well. Okay, so in this situation, you would need to do what we've been doing beforehand. So, for example, x is what we're looking for. Okay, but they give us 28. So 28, let me try this one more time. So the smaller triangle here, let's start one more time. All right, so this would be our long, and this would be our short. Long would be 28, and this part would be 28 minus x. All right, so we could do 28 minus x divided by 28, okay? And then we'd want to have the corresponding side. All right, so here the whole thing, or the short part here would be 12 divided by its whole thing, because that's what we used, is 21. All right? And then when you do that, then you'd multiply both sides by 28. That would give us 28 minus x equals 12 times 28 divided by 21 is 16. And then perhaps we would add x to both sides and subtract 16 from both sides. And would end up getting x equals 12. Okay, there's different ways you can come about doing these problems. Like, for example, if we know that these are proportional, well, I don't know. Maybe I'll just leave it like that. Okay, so if you have any questions about these, let me know. Okay, here's another problem. We know that 5x corresponds to 10. 5x divided by 10 is equal to 12 divided by 8, and we just need to solve for x. So we can multiply both sides by 10. That would give us 5x equals 20 divided by 8. This would give us 15. And then we divide both sides by 5. X equals 3. All right? So not too bad. Here's another one. Do the same sort of thing. This corresponds to this. So x minus 6 divided by 6 is equal to 1 divided by 3. Okay? Multiply both sides by 6. You'll end up x minus 6 equals 2. And then we will just add 6 to both sides. Okay, x equals 8. Okay, so x equals 8. If they asked for what this length right here is, then you just plug it in and you'd find out that it's 2. Which kind of makes sense, okay? So you multiply 1 by 3, that gives you 3. Multiply 2 by 3, and that gives you 6. All right? Last one. All right. Ooh, this one might be tricky. So, let's see. We know that this length, all right, let's think about this. I did this a little different on my notes, so I'm just thinking of a better way to go about doing this. Okay. So, yeah, let's do it this way. Okay. All right, so this length is 21. What could this be? It's proportional side. Okay, well, you could say, well, this whole thing is 2x plus 17. So if we wanted to find this part, we would need to subtract 21 to give us this. So this could end up giving us 2x, and 17 minus 21 would give us a negative 4. All right, and then here we know this is 8. What would this be? 20 minus 8, which gives us 12. All right, so now it kind of is set up so it's more like A. So we could say 2x minus 4 is proportional to 21, and that is equal to 8 divided by 12. 8 and 12 are proportional. So just remember that this is only is when we have parallel lines. All right. So, for example, multiply both sides by 1. That cancels. Let's see what that gives us. 8 times 21 divided by 12. That gives us 2x minus 4 equals 14. Add 4 to both sides. So we get 2x equals 18, and x equals 9. Sweet. All right, so like I said, you are welcome to keep everything so that it is like our long side divided by our small side is equal to the long side divided by the small side. But that said, you'll just need to make sure you have everything filled in correctly. Okay, and if you'd like to keep that all the time, that's fine. It will take a little longer, but you're welcome to do either way. All right, let's see, we have, all right, last one, right triangle similarity. Okay, the altitude or height, which would be this, of a right triangle splits a triangle into into a set of 3 similar triangles. So look at that. We've kind of talked about this at the very beginning where we had that first little quiz. How many triangles do you see? So here we have, here's one triangle. here is another triangle, and then this whole thing would be another triangle. So we have 3 triangles, all right? And it says that if they're right triangles, then they are all similar, all right? So we will use that very carefully, I guess. I don't know, whatever. Okay, so it says find the missing length indicated. All right, so sometimes what I like to do is draw the 2 triangles. So for example, one of our triangles could be, well, this one is the one that we need x for. All right, and we could use this as one of the triangles. But you need to know what this is, which you could do 25 minus 16, which gives us 9. So we'd have one triangle where we'd have x and 9. All right, and then we'd need one more triangle. Okay, we know that they're all similar anyway, so we just need to find one other. So we'd want to find one other triangle where we'd have a base and a hypotenuse. Okay, so the other could be, this is also a hypotenuse, so we could do 25, and then x would be the base. All right, and there's different ways that you can do these problems, so if you find it some other way and that makes sense and you like that, then that's just great. All right, so we can say that these are similar triangles and we just need to solve for x. All right, so we know that x corresponds to 25, so this corresponds to this, and we know that 9 corresponds to x. All right, so we want to get x by itself. We can multiply x on both sides, and we can multiply both sides by 25, and we'll end up getting x squared equals 9 times 25, which is 225. Square root both sides, and you get x equals 15. All right, so let's do another example. Pause if you feel comfortable and try and do the rest. All right, so here we have a triangle where we have, you could use this triangle, where we would have a base as x, and our height would be 64. All right, and then we could use another triangle. Perhaps we need to find, we can't use the hypotenuse because we didn't use the hypotenuse on this one. So we'd need to find another triangle. We could use this triangle, okay, where the base would be 100 minus 64. So let me draw this little triangle, which would be 36, and then the height would be x. All right, so these are similar, and we just need to solve for x. So 6 corresponds to x. 64 divided by x corresponds to x and 36. All right, and if it helps, so these would be like blue. X and 36. So this is one triangle, this is the other triangle. All right, and you would do the same type of thing. You'd multiply both sides by x. That would cancel. And then we'd multiply both sides by 36. And 36 would cancel. So we would end up getting 36 times 64. That's 2,300 and, yeah, I'm going to look it up, make sure I got it right. 36 times 64, 2,304 equals x squared. And we'd do the same thing, we'd square root both sides, and would end up getting 48 equals x, or x equals 48. All right, so it looks like all of these problems that we have will just be solving for x. We already know that they're similar based on that we have right triangles. Okay, we just need to find those two similar triangles to solve for what x is. All right, so for this one, we have a, let me just erase that real quick. So we have this triangle. We could do x and 9, and then we need to find another similar triangle. So x for this one is our hypotenuse, so this would be a hypotenuse. So we'd do another triangle would have 25, and then the base of that triangle would be x. So this would be this triangle. All right, do the same thing. X, well, I guess maybe I'll keep the same color coordination. So x divided by 25, so these correspond, and that is equal to 9 divided by x. Multiply both sides by x, and multiply both sides by 25. And we end up getting x squared equals 9 times 25. It looks like that is the exact same, nearly the exact same problem as A, which is 225, or x equals 15, after we take the square root, okay? All right, so I guess there's only a certain amount of problems that we can do that make this look really nice. Again, D, D is very similar to B, but not quite. So let's do this problem. So here we could do this triangle. I'll write it here as x and 100. And then we're going to need to find another triangle that's similar, which could be this triangle, where it has the base of 36 and the hypotenuse is x. All right, so here these are corresponding, so we could do 100 divided by x equals to, these are corresponding, x divided by 36. Okay, so again, make sure, well, maybe write these as red. Okay, so these are the ones, I'm using the red triangle on the top and blue triangle on the bottom, and you need to make it sure it's always like that, all right? Or else you'll run into problems. If you had them switched on one side, the x's would cancel and you would never be able to solve for x. So, okay, multiply both sides by x, and multiply both sides by 36. End up getting x squared equals 36 times 100, which is 3600. Square root both sides, and you end up getting x equals 60. All right. Again,